Welcome to day 26 of our school year. Okay, let's get that filled in. Now our beginning fraction, our denominator, is our total amount of school days, 180. It's our denominator. And our numerator is 26. That's the day we are currently on. Let's find the factors of our numerator, which is 26. Two factors we always know are 1 and the number itself. Using the commutative property of multiplication, I can also write it as 26 times 1. Now I'm going to go through my divisibility rules in an orderly fashion. That means I go to 2, 3, 4, 5. I go in order so I don't miss any. So the rule for 2 is that it ends in an even number. 6 is an even number, so 2 is a factor. 2 times 13. 13 times 2. Then I try 3. The rule for 3 is that we add the digits together. 2 plus 6 equals 8. 8 is not a multiple of 3, so 3 is not a factor. We try 4. One way to check for 4 is that you see if the factor with 2 is even. 13 is odd, so 4 is not a factor. And you can also think 4 times 5 is 20, then 24, 28. 6 is not in that list of multiples, so 4 is not a factor. 5, the rule for 5 is that it ends in a 0 or 5. It ends in a 6, so 5 is not a factor. 6, the rule for 6 is that both 2 and 3 are factors. 2 is, 3 is not, so that means 6 is not a factor. We try 7, 7, 14, 21, 28. 26 is not in that list, so 7 is not a factor. We try 8, 8, 16, 24, 32. 26 is not in that list, so 8 is not a factor. We try 9. The rule for 9 is the same as the rule for 3. We add the digits together. We get 8. 8 is not a multiple of 9, so 9 is not a factor. We try 10. The rule for 10 is that it ends in a 0. It ends in a 6, so 10 is not a factor. We try 11. 11, 22, 33. 26 is not in that list, so 11 is not a factor. We try 12, 12, 24, 36. 26 is not in that list, so 12 is not a factor. Then we get to 13. We have 13. We're done. Another thing to look at is when your second factor is not breaking down anymore, see if it's prime. 13 is prime. It won't factor down anymore, so that when we have a second factor that's prime and we've gone in an orderly fashion, then we are done. So our factors from least to greatest, 1, 2, 13, 26. We have 4 factors. Is that exactly 2 factors or more than 2 factors? It is more than 2 factors, so it is composite. So now we want to figure out what our greatest common factor is. So let's start with our greatest factor of 26. See if 26 works for 180. If it doesn't, then we try 13. So we're making groups of 26. It does not matter what your groups of 26 look like, as long as you have 26 in each group and you do not have shaded with unshaded. You can count to figure out if you have 26 in each. That will always work. But it's also good to use your reasoning, logic, and patterns to help you out too. So I know that each row is 10. So I see that 2 is taken away here, so that means I have 8. 8 plus 10 is 18. And then I just have to go until I get to 26. So 18, 19, 20, 21, 22, 23, 24, 25, 26. I do know that 8 plus 18 is 26, so that helps me. I have 22 left over. Since I have 22 left over, that means 26 is not a factor of 180. And if it's not a factor of 180, it's not common. So now let's try 13, see if 13 works. Same thing, doesn't matter what your groups of 13 look like, just as long as you have 13 in each and you do not have your shaded in with your unshaded. So that's why I always do my groups in my shaded area first, and then I make my groups in my unshaded area. So it does not matter if your groups look like mine. I'm using my thinking of decomposition, like 9 plus 4 is 13. Another thing I look at is, since each row is 10, here I have 6. So if I add 4, that gets me to 10, and then 3 more gets me to 13. 3 plus 10 is 13. 10 plus 3 is 13. Here I have 7. So if I get to 3 here, I get to 10. And then 3 more gets me to 13. 4, I add 6 gets me to 10. 3 more gets me to 13. But I have 11 left over. So I have a remainder. That means 13 is not a factor of 180. So it can't be our greatest common factor. So now let's try 2. I recommend doing your groups of 2 in your shaded area first, so that you don't accidentally mix shaded in with unshaded. In the groups of 2, all these factors will work for the shaded area, because that's what these numbers represent, the shaded area. So now that we have all the shaded area, let's go ahead and make our groups of 2 in the rest of our area here. So we're actually doing division right now, because division is making groups, or can be seen as repeated subtraction, taking out equal amounts. Taking out or making groups of equal amounts is what division is, and that's exactly what we're doing right here. We're making equal groups of 2. Okay, the way I did it, I ended up with 5 groups of 2 in each row. So if I want to find my new denominator, because 2 is my greatest common factor, I have no remainder. So that worked out nicely. So that's, I can count by 5s to find my new total denominator. Total amounts of groups of 2. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. And our numerator, 5, 10, 11, 12, 13. Now that we've done our division with our model, let's go ahead and prove it with our algorithm. So we're dividing by our greatest common factor, which is 2. Okay, 2 times 50 gives me 100. It's one I just happen to know. You want to make sure you have those in your multiplication bag of tricks. Numbers the same, zeros a game, more on top, no need to stop. Let's see, I'm pretty confident I can do 20 times 2 because I'm good at my 2s, I'm good at my 10s. That placeholder moves it over a place. 2 times 2 is 4. Numbers the same, zeros a game, more on top, no need to stop. 20 times 2 is 40. Numbers the same, zeros a game. Add up these partial quotients. 0 plus 0 plus 0. 5, 6, 7, 8, 9. Okay, here 2 times 10 gives me 20. More on top, no need to stop. Numbers the same, zero's the game. Now you may take the numbers that we got over here and try to use them, but we want to try to do it in a completely different way, because if we made a mistake over there and we assume we got everything correct, we're using a false assumption to try to prove it here. This should be completely independent of any other work. This should be, what multiples do you know to help you out? So I don't know that you would know 2 times 13 is 26 without a multiplication chart. So make sure you're using multiples you do know. 3 times 2 is 6. Numbers the same, zero's the game. Add up your partial quotients. 10 plus 3 is 13. Now we still need to check. Divisor times quotient plus remainder. Divisor times quotient plus remainder. Since our remainder for both is 0, and the identity property of addition says when you add 0, it stays the same, I don't need to add it. It's going to just stay the same. So 2 times 0 is 0. 2 times 9 is 18, or 18 tenths, 180. 2 times 3 is 6. 2 times 10 is 20. 26 matches our dividend of 26 here. Check. 180 matches our dividend of 180 here. Check. So our numerator is definitely 23. Our denominator is definitely 90. I'm sorry, not 23, 13. And our denominator is definitely 90. All right, now it's time to fill in our data collection page. Okay, trimester 1, week 6. Today is 9, 13, 19. And our fraction for today is 13 90ths. Okay, let's go ahead and get out our number line. So we did groups of 2. Our last group of 2. 11 90ths, so today is 12 90ths. So we have an equivalent fraction. I'm sorry, in 3s, 4s, 6s, but the lowest term equivalent fraction is 2/15, or the simplest form. And then today is 13 90ths. There's nothing below it, only numbers above it, because it is the simplest form, or our equivalent fraction in lowest terms. All right, go ahead and put your number line away, erase your worksheet, and thank you for joining me.